let me tell you a story about a multinational company who had put their order form on a website, and they were not in book sales. So let's say they were selling books, just for the sake of the example. And it was the kind of like ordinary web form, order form, exactly what you expect. You surf for the books you want to buy, you put them in your shopping cart. You can change the quantity of the number of books you want to buy, etc. And at the end, you proceed through a checkout procedure where you provide your credit card, your home address or shipping address, etc., etc. And you pay with the credit card. Okay, so there was a group of security testers that were testing this website, trying to get in through a lot of different technical means. And one of them got curious about this quantity field, so just for fun, basically tried to fill out that they were buying the large encyclopedia of everything, but only -1 of
Quantity
them.
of -1?
So actually filling in quantity field -1. I had expected some kind of error message, but this order was actually processed. They went through the entire registration process. They proceeded to the checkout, provided the information and shipping address, and submitted the order. Upon which the system reacted, but in a very strange way. What it did was it was issuing a credit invoice for the amount of one encyclopedia of everything.
So how does DDD deal with that?
The main focus of domain-driven design, as in the name, domain-driven, is to try to capture the business essentials, trying to get a strict version of how we think about the business. And in this case, the concept that we're missing was the concept of quantity. And I find that is often the case.
So the code probably said integer.
Most probably.
An integer can certainly be -1.
Oh yes, that was most probably what the code said. So there's actually nothing in the code that talks about the domain. So the way to address this from a domain-driven design perspective would be to take that implicit concept and make it explicit. Basically taking advantage of the type system. If this is a typed language, strongly typed language, which it was at this particular example, and introduce a user-defined type, quantity. And it will not be anything more glamorous than a wrapped int, basically. But at least the type system will talk about quantities now. And we also have a natural place to say that a quantity must be a positive integer. The classical approach to this in-data validation problem is to say that you should validate your in-data. And of course you should do so. And looking around the system, there were probably a lot of places where people had recognized, yes, in this service level method, I need to start out with saying if quantity is less than 0, throw some exception. But
you must do that everywhere.
You must do that everywhere, and at this particular occasion, they missed that. So whereas if you instead once define that quantity must be a positive integer, you will do the similar check inside that class, that value class, the value object of quantity, which is basically the main idea of domain-driven design and domain-driven value objects, that you can actually isolate that piece of understanding into one place, and then the entire rest of the application will leverage on that. Yeah, it's forming a language, part of the language, the domain language about online sales of books in this example.
So it seems like the connection here to the DDD notion of ubiquitous language is pretty obvious, but this isn't the kind of example one usually thinks about with application security. One thinks more about SQL injection and cross-site scripting and stuff like that. How do you apply DDD to those types of problems?
The attack on the business is trying to make the application do something that is violating the business rules, like issuing a credit invoice. Whereas a technical attack, then the goal is more towards that I want to get to your infrastructure, I want to get to your database, where I know I can install scripts, or I can open up SSH connection, I can install an SSH server, trying to reach to the infrastructure of the computer system that's behind you. What kind of like surprised me was that domain-driven design ideas could be applied not only to shield off the attack on business, which is kind of obvious. It's about modeling the business in a strict way, but also it could help avoiding those design mistakes that make attack on the platform possible. The classical example of being the master username, where you find some kind of input field that would probably match something in the database, and you put in an apostrophe or 1 = 1 -- which is kind of like a classical trick to, if that is inserted into an SQL statement somewhere on the where clause, then you will probably end up with an SQL statement that will match any row in that database. So that is a classical, kind of like the classical canonical trick to access any user account.
So you've been talking about like one of the classic SQL injection attacks, and it sounds purely technical, and I'm wondering where domain-driven design fits in.
Yeah. If we take that example with the weird username where the or 1 = 1, if you put that in front of someone administrating that system, their spontaneous response is often, but that's not a username. And they're totally right. It's not a username. It should not be a username. It's an invalid username. But if we look at the code, there's nothing in the code that speaks about username and their validity. Most often, this string is passed around as a string. Any string. It could be basically anything. And the problem is actually that that string is accepted by the model being, yeah, this is a username string. And then when applied to the search clause, data will get mixed up and interpreted as part of the SQL statement, and it will suddenly match. Rows in the database do not intend to match. But if we take that statement, this is not a valid username, and that actually leads us back on the domain-driven design track. So username in this case is actually a domain concept.
And the code is not expressing it.
And the code is not expressing it. And probably we have not expressed that very well in our discussions around this system earlier. So this is not a username. So what is a username? Well, a username is a string which adhere to some rules regarding what letters it can contain, how long it can be, how long it must be. And those rules are probably somewhere in the code to be found, in some regex somewhere, and some matches method call.
But the concept isn't explicit, and because it isn't explicit, it isn't used everywhere that it's needed. And so this sounds a little bit like the quantity example, where what you want to do is make that concept explicit in the code and have some code whose job it is to, represent it correctly, and so everybody else can use it and speak its language.
So the solution is basically the same. We can actually write a username class, and then the first thing we can do is to actually write a failing test case, where we take a username class and feed it with this weird string, and then we say this should not be valid. And as that class at this point of time do not contain any validity checking, the test will go red. So that will be our key to then enhance this class with the validity checking that once and for all enforces the rule of what is a valid username. And now the rest of the code can speak this language.
It's a different way of thinking about this kind of thing than what one usually hears. For example, prepared statements are a more well understood or at least popular answer to how you prevent arbitrary SQL from getting into your code and so on. Do you see that as different? Why can't we just use prepared statements?
First, we must acknowledge that prepared statement is a good way to secure up the connection between the application and the database. However, we should also be aware that if you look at the OVASP top 10 list, it doesn't say SQL injection as being the topmost or the second topmost or third topmost, but it says injection floor. So it's actually a more general concept. The more general concept of if you are dynamically putting together a string which you thereafter use to reach something in your infrastructure, then you are at risk. For example, putting together a string which thereafter is used as a SQL statement.
Okay.
However, it's not only databases that are susceptible to this, and the username actually being a good example, because nowadays most usernames and user accounts do not rely on databases. They're most probably in an LDAP directory somewhere. So the query put to the infrastructure will not be a SQL query. It will more probably be an LDAP lookup.
So now you have to guard against LDAP injection.
So now we've got LDAP injection.
It sounds like what you're saying is that this DDD design practices, if you build a system that way, then you have a more general way of defending against the entire class of injection attacks. Is that accurate?
Applications written today contain these kind of vulnerabilities. So obviously we have not reached out how to solve this, or the solutions are hard to apply by programmers because they have to think about security also, and they've got their heads full of trying to just implement the next story. So that's what I think domain-driven design can give, is to try to attempt to formulate design guidelines like domain-specific value objects, like quantity, like username. Then you are less at risk for, by mistake, leaving small vulnerability windows open. The basic idea of cross-site scripting is that when a web page is rendered, you often render content, and that content is probably taken out of the database. That has been entered into the database at some previous point of time. Let's say a forum, discussion forum website. However, if some author writes a JavaScript in their comment posting, that will end up in the database. And if we're not careful, then that piece of JavaScript will just be inserted into the website as it is and pushed over to the client. This script is actually executed in the client browser. So thus the name cross-site scripting. It's a script which is not from this site, but has crossed over from another site.
So what you're describing is that something that entered into the system in a context where it was data, innocent data, pure data, has moved into a context where it's now being treated as code and executed without that transition ever having been explicit. And I'm wondering if you relate this to the domain-driven design notion of bounded context.
I think it's especially the way to describe it of having the same data that transition through different contexts is very valid. Because it starts off in some kind of bounded context where we talk about entering a blog posting or entering a comment or a post to this forum. Then it transitions over to kind of like the server side where we say, now we acknowledge that this is a posting, it's annotated to this entity being the article that's being discussed, etc., and most probably persisted into the database. And this innocent data is thereafter picked up and transformed again over to the next context, which is the kind of rendering context in the browser. So what's happening here is that over the time of traversing from one context to the next, the data it's not manipulated, but it's misinterpreted. So it's not the data as such that is broken, it's the mapping between the context that's broken. So seen in this slide, cross-site scripting is often described as a bad data problem. It's an in-data validation problem. We should have stopped that data. But actually, in its general sense, it's not. The data, as in the JavaScript forum example, can be perfectly valid in data. But what we're doing wrong is that when we're passing it out, then we are not formatting it, encoding it in a format that the receiver will understand and act upon appropriately. And this is where I think domain-driven design mapping of contexts can help and guide us, saying that whenever we're crossing from one context to another, we should take special care to think about the mapping between the two of them.
Transform it as it goes into the next context in whatever way is necessary to give it the correct meaning to the new context, and not simply naively pass it over from one to the other. So it sounds like what you're saying is that context boundaries form lines of defense.
Lines of defense, and yes, I think that's a good phrasing, but it must also be pointed out that the lines of defense not only on the perimeter, because that is a bad security practice.
Not just border security.
Not just border security. That's actual lines of defense within the application. The cross-site scripting is not about locking out bad data. It's about that we, on the inside of the system, made a mistake when transforming. So we misinterpreted ourselves, and no border defense would guard us against that. But rather being aware that even a pretty small system actually consists of each of it speaking its own language. They might be similar, so the mapping between them might be easy, but they are actually parts talking different languages. Using practices like value objects and actually designing strict APIs help us being aware of those borders and avoiding these mistakes. And that's the kind of where I see that domain-driven design applied to application security actually has got a chance to address failings of being able to get good development habits into the hand of the practitioners so that they avoid writing these small vulnerabilities, but actually describing good design practices that will help them in an unobtrusive way. They do not have to think about security constantly, but they will feel that this kind of design style is natural.
So a natural outcome of practicing domain-driven design is that in a well-designed system, which is all about taking implicit concepts and making them explicit and making them conform to the domain that the software is addressing, and understanding the difference between multiple contexts, because an explicit concept here and an explicit concept here may sound like the same thing and yet not be. If you produce a well-designed system according to that approach, you end up as almost a virtuous side effect with sort of robust internal defenses against exploitation.
It's kind of like, wow, we always knew we should write good code.
Now we have another reason to do it.
Now we actually have a compelling reason for actually write well-designed code.
So to someone who knows the core concepts of domain-driven design, this connection to application security seems really obvious once you say it. And I'm wondering why no one hit on it before. How did you discover this?
There's actually, to some degree, it's lucky coincidence or serendipity to some extent. I have myself nurtured a long interest in domain-driven design and high-quality development habits in general, and also an interest in security. However, it was not until a few years ago when I came across John Wilander, who became a colleague of mine, who's coming from kind of like the opposite or complementary direction, being a security guy with a lot of interest in development. And we came to start, out of curiosity, discuss each other's home turfs. And that was, out of those discussions grew realization that ideas and practices from my home turf, especially strict modeling and context mapping, could be used to understand the phenomenon in his home turf, application security and vulnerabilities. And in the crossroad of these ideas, we coined the term of domain-driven security, just as a collection of trying to funnel the ideas of how to apply domain-driven design ideas for the building of more secure software.